Today we solve multiple step equations. Alright, with multiple step equations, we must remember PEMBAs and we must work backwards. We saw the other day, we have to focus on the addition and subtraction first. 64, negative 8p, divide by negative 8, divide by negative 8, p equals negative 8. And get our answer. We must take those two steps, okay? Today we add something into it to solve multi-step equations. Now, with this, we are going to do what we did the other day, but the very first step is now a little different. You will either use distributive property in the first step, or you will look at each side of the equation and combine like terms. So I will look at over here. I see that I have a like term of negative 7b and positive 10b. Those are like terms. I should combine them. So I would get 12 plus 3b and have that equal 18. Once I've done that, then I can go back to my same thing. Remember, we want to get the variable by itself, but we must first focus on removing the addition and subtraction, working in reverse order when we're working backwards to solve problems. So then we get 3b equals 6. Divide by 3, divide by 3, b equals 2. This is order and organization, doing things in the correct order. No problems from there on out. You've got the pretty problem. Let's watch what they set up for us. All right. In the first step, they're going to have you add like terms or combine like terms. Now, we want to focus on that 12 and get rid of it, subtracting 12 from each side. Then divide by the 3 because we're isolating the b. All right, and we get our answer of 2. Here, look at each side. Over here, I see like terms of negative 8b and 12b. That makes for a 4b. 14. This is positive when it comes together, so it is an addition problem. Equals 62. We'll subtract 14. We'll subtract 14. That gets us 48. 4b equals 48. Then we therefore divide by 4. Divide by 4. b equals 12. And if you want to, you can plug 12 back in either here or into that equation and get your answer. Adding like terms first, then working on the addition and subtraction, then working on the division and multiplication. 1, 2, 3 steps. I will be looking for work. I will be looking for those steps out. For some of you, make sure you show it because it's a required thing to be finished with the project. All right. So, they combine like terms. Did it. Then they focus on the 14 and get rid of that addition or subtraction. It was minus 14 because it's positive. 4b equals 48, so we're going to divide by 4. And we get our answer of 12. You may need to use the distributive property to solve an equation that has parentheses. Multiply each term inside the parentheses by the factor that is outside the parentheses. Then combine like terms. So adding one more thing to it. What they're saying is 2 times 3. 2 times 5. So we would get 6 plus 10, which is 16. Or we could have 8 times 2, which is 16. You come up with the same answer. But this is helpful when there's variables because we can remove those parentheses so we can work with other things. All right, so this is showing you that it works and makes sense, and it's helpful when there's variables. So, distributive property. 5 times y, well, that's 5y. Bring down the subtraction sign. 5 times 2 is 10. Bring down the other things you did not work with. From there, combine like terms. Positive 6, negative 10, negative 4, 5, y minus 4 equals 21. We add a 4, we add a 4. 5y equals 25. We do our division, y equals 25. Y equals 5. This will be a good one to go back at. We have distributive property. We have combining like terms. We get rid of the addition, then we get rid of the multiplication or division. All right? It shows all 4 steps, so if you need one to go back to again and again, this might be your one. All right, here they are. They use their distributive property. All right, they multiply that out. There we go. Then they did it all. They multiplied it and combined like terms, all in that one step. Then they add 4, then they divide by 5, and then they get their answer. So, if you like my written way better, that's fine. I did show it out a little step by step more so. 3 times x. 3 times 3 is 9, plus the 4 equals the 28. I think it's dangerous to do all that combining in one step. Negative 9 and positive 4 gets me a negative 5. Bring down what you didn't work with. No, I'm going to add 5 because we work on the addition and subtraction first. Add 5. That gets me 33 over here. Gets me 3x. Divide by 3. Divide by 3. Then x equals 11. Again, another one where it shows all the steps. Distributive property. Combining like terms. Working with the addition or subtraction first. Then working with the multiplication or division. Alright, here we are. Distributed the property. Then they combine like terms in that same step, which is a little crazy to me. But now we're down to the problem that I had. They add 5 on each side. Then they divide by 3 on each side. And you get your answer of 11. Troy owns 3 times as many trading cards as Hillary. Subtracting 9 from the number of trading cards Troy owns and then dividing by 6 gives the number of trading cards owned. If Sean owns 24 trading cards, how many trading cards does Hillary own? Let's understand the problem. There are a lot of words there. Okay? Troy owns 3 times as many trading cards as Hillary. Subtracting 9 from the number of trading cards that Troy owns and then dividing by 6 gives the number of cards Sean owns. Okay. Sean owns 24. We know all that information. So this one is very in-depth and complex. Okay. So 3 times this minus 9 divided by 6 equals 24. The number of cards that Troy has is 3 times what Hillary has. Okay. Now, if we subtract 9 from that and divide by 6, we get 24. Okay, so we have this problem that we're supposed to work with. Pretty complex. Here would be my suggestion. Think of that as parentheses. I'm going to multiply this side by 6. I'm going to multiply this side by 6. Do you see how 3c minus 9 is all one item there? And that has a variable in it. Therefore, if I multiply this whole side by 6, and I do the same thing over here, it's kind of like using the distributive property, except, I would get 3c minus 9 equals 24 times 6. I'm going to do that over here just to make sure. I believe that's right, 144. Now I'm ready to work with the problem I have. We got rid of the 6, or that denominator that was under both of them. All right, we're going to add 9, add 9. All right, so we have 153 equals 3c. Divide by 3, divide by 3. Okay, we put that in there, and that would be 51 cards for Troy. Okay? That was a roundabout way of saying the problem out, wasn't it? Let's go ahead and look at what they do. They threw something new at us, and hopefully we handled it all right. Okay? Multiply both sides by 6. By doing so, we get to cross out those 6s. All right, on my about fourth one. I got to get a drink after this one. All right, we added 9 to each side. I think they wrote it a weird way. Then we divide by 3 on each side, and we get our answer. All right. We look back. If Hillary owns 51 cards, then Troy owns 153. Okay. Oh, 51, and then it was times 3 for Troy's. Troy owes 153. I forgot there were 2 steps. Don't forget to come back and get, oh, Hillary has 51, so Troy has 153. Don't forget those steps. All right. John is twice as old as Helen. Subtracting 4 from John's age and then dividing by 2 gives William's age. If William is 24, how old is Helen? So John is twice as old as Helen. Let's do A for age. So 2 times A will give us John's age. Now, once we've got that, if we subtract 4, this is John's age, from John's age, and then divide by 2, that gives us William's age of 24. Okay. I'm good with that. In the first step, you're going to want to multiply by 2. You're going to want to multiply by 2. These will cross out, so you would get 2a minus 4 equals 48. Many of you are probably going, but 2 goes into that. This is a weird situation. Do you see how the subtraction sign is above there and it's all one fraction? If you're going to reduce, you're going to make sure it goes into all 3, which it does in this case. But many times it's simpler to multiply by that and get rid of that denominator. From there, we add our 4. We add our 4. 52. 2a. Divide by the 2. Divide by the 2. A is 26. All right, so Helen is 26, John is 52. That's my predictions for the answer. All right, so we look at all the information we have. Helen's age, that's what we want to find. John is 2 times as old as Helen. Subtracting 4 from John's age, dividing by 2, that gives us William's age. William's 24. Make a plan. Oh, 2 times h, which would be Helen's age. I used an a for it. All right, minus the 4. Divided by 2, that gives us William's age. Now we got our equation going. All right, so multiply both sides by 2. We did write that down, yay. All right, there. Then we're going to add 4 because we want to get rid of that the addition and subtraction first. I don't like the way they wrote it there. Then 2h equals 52. Divide by that. So Helen's age is 26 years old. Look back. If Helen is 26, John is 52, because 2 times Helen's age. And you get, when you subtract 4 from 52, you get 48. And 48 divided by 2 is 24, which is the age of William. All right, so they were going from John to William just to make sure it was correct. So Helen 26, John 52, we did do good. All right, good job, guys, and good luck.